Hello, my name is April Brito, and today I'm going to be solving the initial value problem using the Laplace method. So first, we're giving the problem y double prime plus 16y is equal to the unit step function minus the delta function of t minus 1, with the initial values of y of 0 is equal to 0 and y prime of 0 is equal to 1. So the first steps that we're going to need to solve this problem is going to be to take the Laplace transforms of both sides, solve for y of s, which is going to be the same thing as the Laplace transform of y, and then use partial functions to find the inverse Laplace of these of our new function y of s or the Laplace of y. And then finally, when we do that, we're going to get our answer, and then we're going to be able to simplify it to the best of our abilities to get a more clear, definite answer than from step 3. So important information to know is that we're going to need to know some Laplace transforms that are given to us from our table in our textbook. The main ones that we're going to be using today are going to be the Laplace transform of u of t, the Laplace transform of the delta function, the shift functions, and then just to get us started, we're going to need to remember the initial values, and then also the Laplace transform of y double prime. So to start off, we're going to do step 1, take the Laplace transform of every single term. So we're going to be separating double prime, 16y, the unit step function, the delta function. So here we have the Laplace transforms of each one. We're going to keep this one the same for right now, and then combine and plug in our initial terms. So here we have where we plugged in 1 and 0, and then combine our like terms right here, since these two are the Laplace transforms of y. And here is our simplified problem. So now we need to solve for the Laplace transform of y. This is pretty simple, straightforward. All we need to do is divide both sides by s squared plus 16. So once we do that, we're able to cross this out, and this is our L of y isolated. So now here, all we're going to do is we're going to separate the top and the bottom. So we're just pulling this out here up front, and then creating a second term where it's 1 over s squared plus 16. Now here, what we're doing is we're going to distribute this substitution right here, where f of s is equal to 1 over s of t, just so that we can get the fraction out of the way for a second and focus on the rest of the problem. And then we're just going to distribute it to the rest of the equation. So that leads us to step 3, where we're taking the inverse of the Laplace. So this is very similar to step 1, where we took the Laplace transform of each term. Now we're doing the same thing, except it's the inverse Laplace. So here we have the inverse of each term, and we're just going to set this equal to y of t, which is going to be our answer at the end. And for this part, we're separating it into two parts, where we're taking the inverse of this first term right here, and then taking the inverses of these last two terms right here. So starting with these last two terms here, we're pretty simple, straightforward. The unit step function right here, right? And so we're just to simplify it, since we're working on the first part now, we're just going to set it equal to h, so that don't have to write it every single time. So here, what we did, we just plugging the f of s back in our substitution that we did up here. We're plugging it back into this equation, and now we're going to be able to solve it. Just distributing the s right here. Now we need to use our partial function, our partial fraction decomposition in order to solve for it. So here we're solving for s and a, b, and c. And now we're just plugging this in right here. So we have this answer right here is what's going to replace our first term right here. So here we are. This is now what our first term is, and like we did before, we simplified the second term to h. Now we see that 1 over 16 occurs on both terms right here. So we're taking it out of each term and then solving the inverse Laplace, which is pretty straightforward. Here we get 1 over 16 times 1 is minus 1 over 16 times cosine of 4t, and then our minus h, bring it back down. So this is simplified all the way. We solved the inverse Laplace. So now we can plug h back in. So this is what our answer technically is going to be. We have y of t is equal to 1 over 16 times 1 minus cosine of 4t minus the u step function t minus 1 times f of t plus f of t. So now here all we have to do is simplify our answers. So here we have just remembering that we changed f of s to 1 over s squared plus 16, and that f of t is equal to the Laplace, the inverse Laplace of f of s. So solving the inverse Laplace of f of s, which is this term right here, we're going to get our the answer 1 over 4 sine 4t. So now really all we have to do is plug everything back in. So here we have it, where we plug in the inverse of f of t right here. And then now we just need to find the values to where we can get a more accurate answer to a more descriptive answer to our problem. So here we see that whenever we plug in 1 here to our second and third terms, we get 0. So we'll be able to base our answer off of that, where y is equal to 1 over 16 of t minus 1 cosine, of 1 over 16, 1 minus cosine 4 of t plus 1 over 4 sine 4 of t is our answer whenever t is less than 1, and then our answer is 0 whenever t is equal to or greater than 1. Thank you so much for watching.